Hello everyone. Today I am going to cover some important topics for GPAT and NIPAR as well. This is actually very important from this part. 2-3 questions in an average you can expect in the exam. Okay. So see. So this is the actually I am going to cover the trick part. Okay, tricky part. So you can remember these values more confidently. Okay. So see the corresponding index, actually this is related to flow character. Okay, so we need to understand how is the flow character. So for flow character measurement or the analysis, we come to three formulas, that is, one is Kar's index, another one is Hassner ratio, and another one is angle of repose. So first the Kar's index. So Kar's index is written as tap density minus bulk density by tap density. You people know tap density, what it is actually. So usually tap density means actually there are bulk density, whatever the material we have, like active pharmaceutical ingredient or some other excipients or any compound, okay, in a whole. So what happens, the density in the normal state, that is the bulk density. Okay, what we do, we tap those component or the material to get the tap density, right? We apply some type of shaking, right? We do some shaking, then after that tap density is measured. Okay, so tap density minus bulk density by tap density, this is the Kar's index. So you think now think a condition like tap density is same for two material. We are considering two material, material A and material B. So the tap density, just imagine that tap density of material A and material B is same. So the lower part is same for both, but the difference in the tap density minus bulk density, this will measure or give the Kar's index difference, right? So in case of tap density minus bulk density is different for two component, then whatever the component which is having difference in more amount, the Kar's index will be more. So what is actually the case? So see the component, the material we took, that material may have some void place or free space inside their structure, means many molecules are present inside the material. Then the free space, if we have that free space more, then it is very obvious that the difference between tap density and bulk density will be high. So if the free space is less, the difference between tap density and bulk density is going to be very less, right? So this helps. So that means whether it has more void space or free space inside the material or not. If it is present in high amount, then the difference between tap density and bulk density is going to be high. So the Kar's index. So you got the point. So the void space is actually measuring the Kar's index. So what happens when void space is more, then the material is sticky in nature. Okay, so this is the reason behind the flow property. So more the void space or free space inside the material, more is the stickiness and less is the flow property. So that's why here you can see the Kar's index. The more is the Kar's index, means flow character is getting down, right? And even Hassner ratio. So the formula for Hassner ratio is tap density by bulk density divided by bulk density. So if we have two material both having same bulk density, but one having more tap density, means more free space, more stickiness, so Hassner ratio will be more, and Hassner ratio more means less flow character. Okay, so in both case Kar's index and Hassner ratio, if we increasing that the value of Kar's index and Hassner ratio, that means flow character is getting down. So here you can see the values of Car's index and Hausner ratio that measuring the flow character. So less than 10. Okay, so less than 10 means excellent. So we need to remember the values first. So less than 10, then 11 to 15 means 5. Again 16 to 20, again 5. 21 to 25, 5. Okay, next one is the 26 to 31. This is 6. Then 32 to 37. This is also 6. And greater than is equals to 38. This is the last one. Okay, so this is the values. So flow character is getting down if we increase the Car's index. Now coming to the angle of repose. So angle of repose actually tan theta. We know tan theta. Theta is the angle of repose. So tan theta is equals to height of the material when we make them settle on the ground. Okay, or the whatever the paper we have used in the experiment. I think you people did this experiment in the laboratory. Okay, in the Ceutics laboratory, pharmaceutical engineering classes. Okay, so what happens when we measure that height? Okay, so the measure of height divided by the radius of that material formed on the ground. So height by radius. So if stickiness is more of the material, if stickness is more, or the void space or free space is more, that means the radius will be less. Sorry, okay, the height will be less. Yeah, the height will be less. Angle of repose and flow character. As we increase the angle of repose, flow character is getting down. Similar with Car's index and Hausner ratio. For angle of repose, measuring angle of repose theta is equals to tan inverse height by radius. So as we increase the height, that means the angle of repose is getting high, so flow character will be less. So more height means more stiffness, more free space, more void. So that's why that is the material is making more height on the ground when it is falling from a specific height. Okay, so more the height it is making, the more is the stickiness, more is the free space or void space inside that material. And radius, as height is increasing, the radius will be less. So this is the basic things. So the values are there here also. Mostly difference is 5, 25 to 30, excellent, then good, then fair, passable, poor, very poor, and very very poor. Mostly the difference is 5, 25 to 30, 31 to 35, 36 to 40, 41 to 45. The next one is difference of 10, 46 to 55, then 56 to 65, and more than 66, that is the very very poor. So these three formula we need to remember very frequently. Okay, we need to revise this very frequently so that we remember it properly. This is very very important. Okay, so study well, all the best.